the words aren't really in the question. You're not going to see AER. I know I have it there as a heading, but you're not going to see it in the question. But just to be aware of how we might approach something like this. Calculate the compound interest. That suggests that we use the compound interest formula. If 20,000 euro is put in savings for 5 years, but we want to know how often we're going to be paid throughout the year. So in the first case, we're told that interest is added annually at 4% per annum. In other words, that would be the equivalent of 4% compounded annually. Can anyone tell me there what the nominal rate of interest is? The nominal rate is 4%, isn't it?
Yeah.
What's the real rate of interest? Can you tell me what the real rate of interest without having to do any calculation? Okay, let me just repeat what I had said earlier on about the difference between nominal and real. Okay, the nominal rate of interest is typically an interest rate that's just given to you initially, and we may not know how often we get paid interest on our savings. Okay, and if we find out how often we get paid on our savings, then we can create a real rate of interest. So if you get paid more than once in the year, then your real rate of interest will be higher than your nominal rate. So your nominal rate here is 4%. Are we going to have a higher rate of interest here? No. So you see here, interest is added annually. So we're only being paid once. So therefore your nominal is your real rate of interest. So if we had, for example, gone back to this one here, if you can put in the 4% instead of the 9%, so that becomes 0.04. Instead of the 12, you put in 1 because you're only being paid once to the power of 1. And all of that, if you work through that, 0.09 divided by 1 is 0.09. Added onto your 1, so 1 plus 0.09 is give us the 1.09 to the power of 1. Minus 1 will give us the 9%. So you don't have to do the calculation if you were aware of it. So notice that your answer here, you do not have to do the annual equivalent rate because your 4% will be the same as your 4%. Let's have a look at the next part. What about this one? What's your nominal rate of interest? Both of those rates are nominal rates, but we want to find out what the real rate is. So because you're only being paid once, the real rate is 4% as well. And because you're being paid 4 times in the year, can you tell me whether the real rate is going to be the same or higher than the nominal? Yeah, it'll be higher, okay. So that 2% is your nominal rate, but now that we know that we're going to be paid 4 times a year, we're going to have to get a real rate of interest. I don't know what it is. So how do we find out? What are we going to do to find out what the real rate is? We're going to use the annual equivalent rate formula, okay? So if you see this here, you're not going to see calculate using the annual equivalent rate. You're just going to see what you see exactly in front of you. And what you know here is that interest is added quarterly, or I might say 2% compounded quarterly. And because of that, you have to use the annual equivalent rate. So let's just go back to part 1 first, okay? And let's do that, and then we'll move on to part 2. Because we know we don't have to get the real rate of interest, because 4% will also be the real rate because it's only being paid once a year, we can go straight into finding out what the compound interest is on your savings of 20,000 for a 5-year period. Again, the formula is given to you in the exam. That second formula, compound interest, okay? It looks like the depreciation formula. The only difference is, apart from the few letters, is that you have a plus instead of the minus, and that plus indicates that it's going to be higher. Anyway, interest is added annually at 4% per annum. All right, so we plug 4% into where OR is in your second formula, so that becomes 0.04. We were told that there was 20,000 euro in savings, so that's your initial deposit, which is called the principal, P. You have also n here to the power of n, which is the number of years you're going to leave it in your savings deposit. And again, going back to your question here, calculate the compound interest due on savings of 20,000 euro for 5 years. So n is 5. So when it comes to compound interest, n here, I don't know if you have a pen and paper or anything like that, but when it comes to compound interest, n is to do with the number of years. What does n refer to for the annual equivalent rate? Anyone? Is n to do with, yeah, it's the number of times, or the frequency, the number of times you get paid interest throughout the 1 year. Okay, that's what n is for annual equivalent rate. So the number of times within a year. whereas compound interest, the N there is the number of years. So plugging those values into your formula, P being 20,000, or being your 4%, so that's why we have the 0.04 added onto the 1.04 to the power of 5. So 1.04 to the power of 5 will give us that next part, 1.21665, and multiplying that by 20,000 will give us your 24,333. So that's what you see your savings was 20,000. It gets compounded over a 5-year period, and you earn interest of 4,333. So that's how much interest you have. So, get to know that question. That this is going to help you out, okay? Your next part 2, we have interest added quarterly at 2%. I prefer to say compounded quarterly, 2% compounded quarterly. If you see something like this here where it says quarterly or monthly or semi-annually, it just means that you're going to be paid that number of times throughout the year. Therefore, you have to use the annual equivalent rate in order to get your real rate of interest. That indicates to you that you have to use this formula, the AER formula. I'm just going to go back on the screen to show you that formula. By the way, I thought I had it here, but there it is on the top. 1 plus OR divided by N to the power of N. So OR was your 2%. So 2% divided by 100 is going to give you your 0.02. Divided by N, N is 4 to the power of 4. Okay. So 1 plus 0.02 divided by 4, close your bracket, to the power of 4, okay, will give us these values. So if you have a calculator handy, it might be ideal just to double check on this, and so you're comfortable with the way this is calculated. So 0.02 divided by 4 will give us your, whatever that is, 0.005, add that onto your 1, and then get that to the power of 4 should give us that 1.02015. So here's your compound interest part now. So again, if you recall the formula, the compound interest A is equal to times 1 plus R to the power of N. Okay, the rate of interest or in your compound interest is going to be that here 2.015%. So 1 plus that real rate of interest will give us your 1.02015. Get that to the power of 5. 5 here now is the number of years you're going to leave your savings and on deposit. Working through that, then you end up with €22,098. You'll notice that your initial investment here or deposit is 20,000. It has grown by 2,098.